Myself Padmaja, Associate Professor, Department of CSE, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss about pointer concepts in C language. So, first of all, let us understand what is a pointer. Now, pointer is like a variable which is a special type of variable which normally holds the address of another variable. Now, pointers are represented by the indirection operator star, and whenever we are using pointers in our program, then the program execution will be faster, and pointers are normally used for low level programming. That means for making the softwares like your assembler, compiler, loader, linker, and so on. So, whenever you are using a pointer, first of all, you should know how to declare the pointer. So, the syntax for pointer declaration is, first of all, you have to write down the name of the data type followed by the pointer name. So, this indicates that suppose we are declaring int star p. So, here int is nothing but the data type and star is nothing but the indirection operator, and which indicates that it is not a simple variable which stores a value, but it is a variable which stores the address of another variable, and this ptr is the name of the variable. So here p is the name of the variable, star is the indirection operator, and int is the data type. Similarly, you can see in this declaration int star p, p1 comma p2. So here p1 is nothing but a pointer type variable which is going to store the address of another variable, whereas p2 is just a normal variable, so which can store a value. So the difference between a normal variable and a pointer variable is indicated by keeping a star mark. So for example, here we have declared a pointer int star pc, a pointer, and c is a normal variable. Now initially c contains 5. So here c is nothing but a variable which initially contains 5. Now this variable will have an address. Suppose the address of the variable is some 2000. Then what you are doing, we are creating a pointer variable pc which contains ampersand of c. That means which contains the address of c. What is the address of c? Is 2000. So 2000 is stored over here. That means we can say that this pointer pc is also pointing to p, that is indirectly. So this is called the declaration of pointer. Now let us understand more about the formatted input functions, or let us understand about the pointer declaration. Now in this pointer declaration, we are using the ampersand, that is called the address operator. For example, y is equal to initially 5. Now we have declared one integer pointer. So to store the value of a variable, we declare a normal variable, but to store the address of a variable, we declare a pointer variable. Now here, the type of value, the y contains an integer value. So the pointer which you are declaring to store its address, suppose its address is 1000. So the pointer which you are declaring to store y's address should be also integer type. That's why this both should be integer only. So this is an integer pointer which holds the address of an integer. So 1000 is the address of integer. That means this pointer is also indirectly pointing to 5 only. So we can write like this: ptr is equal to ampersand of y, because y is an integer variable, so pointer should be also an integer pointer. So you can see here a pointer points to the value 5 indirectly. Now in this case, this is the representation. Suppose 5 is a variable, or y is a variable which contains 5 is the value inside it, and this is having an address. So that address will be stored into the pointer, and though pointer is also a variable, so pointer is having its own address. Okay, so the address of y is the value of ptr always. Now let us go for more in detail about different ways of pointer declaration. Now, so the basic syntax is data type followed by indirection operator and then a name. So data type star name. So star ptr. For example, I want to declare an integer pointer. So int star ptr1. I want to declare a float pointer. So write float star ptr2. Any name you can write. And this pointer names also follows the rules of identifier. So character pointer char star ptr3. So we have declared one integer pointer, one float pointer, one character pointer. Similarly, if you want to declare an array of pointers, that means a normal array contains the value. Suppose if I'll write this is 0, 1, 2, 3, 4. This is array A and it has 5 slots. So it normally contains the values. So this is array of values. If you write A of 5, this is called array of values. Similarly, if you will put a star before it, star A of 5, this is called an array of 5 integer pointers. Array of pointers. Now, what do you mean by array of pointers? So, as you have declared this to be integer, that means suppose there are 5 simple variables A, B, C, D, E. Then these variables are somewhere in memory. Suppose it contains 10, 20, 30, 40 and 50. Some values are there in the variables A, B, C, D. Now each variable will have its own address. For example, the address of the first variable is 1000. Suppose here it is 2000, here it is 7000, here it is 5000, here it is 4000 something. So each variable have its own addresses. Now we are declaring integer star A of 5. That means we are declaring an array of integer pointers to store. So that means now the array which you are declaring, the name of the array is A only, containing 5 slots. So 0, 1, 2, 3 and 4 containing 5 slots. Now each slot A of 0 contains the address of the first variable's address, that is suppose 1000. It contains 2000, which is nothing but the address of, it is referring to the value 10 indirectly. Now it is containing 2000, it is referring to the value 20. Now it is containing 7000, it is referring to this one, and 5000 it is referring here, and 4000 it is referring here. Understood? This is called an array of 5 integer pointer. That means the array contains 5 integers addresses. Okay. Now next we will go for a function pointer. Now a function pointer which can store the address of a function. So whenever you declare a function, that function will be somewhere in memory. So every function has its address. So if you want to explicitly store the address of the function, then you have to declare a function pointer. So suppose f is a function which is in memory. So this function will have an address. Okay. Now we can create a function pointer like star f. This is a function pointer which can store, suppose its address is some 2000, then it contains 2000. That means it is indirectly pointing to the same function. So f is a function pointer which can store the address of a function that takes no arguments and returns an integer. So based on the way you have written, because functions can be written in 4 ways: with arguments, without arguments, with return type, without return type. So based on this, you can declare a function pointer of same type, with arguments or without arguments, with return type or without return type. So here you have declared a function pointer. F is a function pointer which holds the address of a function, but that function takes no argument and that function returns some integer. That is the meaning over here. So whatever, whether it is a variable or an array or whatever the type of variable or type of function you are taking, whose address you are going to store, the same type of pointer you have to declare. That is the key point you have to remember here. Now let us go for another example. Pointer to an array. Pointer to an array. That means here int star p of 3. That means there is an array of size 3. Okay, 0, 1, 2. So here whenever you are addressing or referencing an array through a pointer, the array may have a name or may not have a name. That doesn't matter because the array is having an address. Suppose the starting address of the array is 1000. If it is an integer type, so the each slot is 4 bytes. So the next address will be at 1004. Next address will be at 1008. Each slot will be of 4 bytes each. Suppose there are 3 slots like this. Okay. Now for this array, the starting address is 1000. So now we are creating a pointer. This pointer p contains the address of an array. This is called a pointer to an integer array. So suppose this integer, it contains 3 integer, 10, 20, 30 something. So here p is a pointer to an integer array. In the earlier example, we have seen that we have created an array of integer pointers. But in this case, array is a normal array is there whose address is there in a pointer. So this is called a pointer to an integer array whose size is 3. Okay. Now, then we'll go for how to create a constant pointer. Now, constant pointer will always point to the same location. So if you will take a constant pointer, you have to declare int star constant p. So here, p is a constant pointer, okay, which always points to the same location. So it is fixed address. Okay. Next, pointer to a constant integer. Suppose there is a constant. Suppose we declare constant int I is equal to 10. So here, int I is equal to 10. This is a constant value. So I contains a constant value in a particular location, suppose 2000. Now here, constant integer p, that means p is a pointer pointing to a constant integer. So p is a pointer which contains the address of this constant. So this is called constant pointer. So pointer to a constant integer. So constant int star p you have to write. So hope you understood the difference between constant pointer and a pointer to a constant integer. Both things are different. Again, I'll repeat. Constant pointer means the pointer which always points to the same location, which always refers to the same location is called a constant pointer. But a pointer to a constant integer means there is an integer which is of constant type because its value won't change during the program execution. That is a constant integer. That integer's address is held by this pointer. So it is called a pointer to the constant integer. So there is a difference in the declaration. Now, there is another type of pointer declaration is called generic pointer declaration. What is generic pointer declaration? Generic or void pointer is a pointer which can hold the address of any kind of data type. Okay, so the same pointer can be used to hold the address of an integer. It can also be used to hold the address of a character or a float or a double value, but it has no type basically on its own. So we will use the mechanism of typecasting to convert into an integer type, integer pointer when you want to hold the address of an integer. When you want to hold the address of a character, we will convert this void pointer into char pointer. So this way, explicit typecasting should be used whenever you want to convert the pointer to of that type. Okay. So these are the different pointer declarations. Next, we will talk about what are the different types of pointers. So we can basically divide the pointers into several types. One is called based on how many stars you are writing, how many references you are creating. If you are just creating a single reference, then it is called a single pointer. Then second one is called double pointer. Your pointer to pointer is also known as double pointer. And similarly, you can write triple pointer and so on. So it can go up to any extent. So you can have a multi pointer or n pointer. So whenever it changes from single to double and triple, the number of stars will increase whenever you declare the variable. And we call it the level of indirection increases. Okay. In single pointer, the level of indirection is 1. In double pointer, the level of indirection increases to 2. In triple, it increases to 3. In multi-pointer or n pointer, the level of indirection reaches to n value. So there is no limit on the n value. Now, let us discuss about what is a single pointer. Now, single pointer holds the address of a simple variable. It holds the address of a simple variable. Now, let us understand this through one example. Suppose int x is equal to 10. So, x is a simple variable which contains the value 10. So, every variable has two things. One is called a value, and if I'll ask you where is x, that means x will have an address. Suppose the address of x is some 1000, for example. Then we have declared to store the address of an integer, we need an integer pointer. So we have declared a pointer called ptr. Okay. Now this ptr contains the address of x. So ptr is equal to ampersand of x. That means this 1000 is contained into this pointer. That means this ptr is indirectly pointing to the value 10. Okay. Now, let us print the address of x in different formats. So, the address of x in decimal format, you have to write %d as the format specifier. So, in this example, when you run, suppose this is the actual memory address of that x So in decimal form, you will get a big number which indicates or shows the address of the variable in memory. So you can see this is the output that I have got. Second, if you want to see the address in an unsigned decimal format, you have to write percentile U. So whether you write percentile U or D, addresses are normal positive integers. So it is better to write percentile U. So in percentile U also, we are getting the same address. Now, if you will find it out that what is the address in base plus offset form, okay, in base plus offset form, that in your memory segment, in your different types of segments are there, in that segment there is a base address and this location is there at what offset. So base plus offset, if you will add it up, then you will get the actual address. So if you will see in that form, you will get a very big address, which is nothing but the segment starting address plus the offset address together. This is the address of that particular X memory address. Now, if you want to display the address in the hexadecimal form, then this is converted into a hexadecimal form. Can you observe here? 62FE14, the last digit normally the addresses are in hexadecimal form. So you will see the address in hexadecimal form over there. If you want to see the address in octal form, then the hexadecimal value will be converted into octal and you can see the address. Similarly, if the value of X using pointer, if you want to access, then if you are writing star PTR, PTR contains the address of X, star PTR means the value inside that area. So that is nothing but your 10. Simply, instead of, this is called indirectly accessing the value of X. If you want to directly access the value of X, directly write value of X, that will be printed as 10 only. Okay. Now, I want to modify the existing value of X. So, initially the value of X is 10. If I want to modify to 25 through indirectly or through indirection, that is through pointer, then I can write star PTR is equal to 25. Star PTR. PTR contains the address of X. Star PTR means the value in that address. So, the value in that address is 10. It is now changed to 25. Now, the value of X changed to 25. So, if you want to see after the value of X, after updation, what is the value? If you will print it, you will get the value as 25. Now, similarly, if you want to do some small arithmetic operations, you can do it. Like star PTR is equal to star PTR minus 3. That means star PTR. PTR refers to an address. Star PTR means the value that it is pointing, which is nothing but 25. So, here it will do 25 minus 3. Okay. So, the output is 22. So, if you will see that the value of X after updation is 22. So, this way, using single pointer, you can refer to or you can store the address of a variable. You can do some operations on that variable, that is indirect. Now, the second type of pointer is called double pointer. Double pointer or pointer to pointer, two level of indirection. So, we can simply say the definition as it holds the address of a single pointer. And what is a single pointer? A single pointer stores or holds the address of a simple variable. So, there are two levels of indirection. So, we can say that P is a pointer, okay? Star P is a pointer which holds the address of a variable. Suppose X is a variable which contains 10 inside it and the address of X is suppose 1000. So, a star P single pointer contains 1000. That means it is referring to 10. Okay. Now, double pointer, suppose PP, star PP is there, which is a double pointer. So, double pointer, this single pointer will also have its own address. Suppose the address of the single pointer is 2000. So, the double pointer contains the address of the single pointer. So, now it is referring to 1000. So, a double pointer holds the address of a single pointer. A single pointer holds the address of a simple variable. So, that means indirectly this double pointer can also access to the value 10. Now, the same example I have talked here. So, integer X is equal to 10 and I have declared one single pointer, one double pointer. Now, single pointer contains the address of X. It holds the address of a simple variable. Double pointer holds the address of a single pointer. Then you can print what is the address of X. So, suppose this is the address of X. What is the address of double pointer, which is nothing but the address of the single pointer. So, this is a different address. Then, what is the value in star PP? That means PP contains the address of a single pointer. That single pointer contains what? It contains a the address of a simple variable. So that will be displayed. What is double star double P? That means it is indirectly referring to the value 10. Okay, and it is indirectly referring to the value 10. So using double pointer also you can modify the value. Double star PP means you are indirectly changing this value to 25. And if you want, you can check the value of X through, by printing the value of X, you can check whether it has updated or not. So this is called double pointer. Now, double pointer, we can see one more example for characters. So, suppose there is a character I is the name of the character variable which contains a character A. And there is a character pointer CP which contains, suppose the address of this A is 1000, CP contains 1000, that means CP is pointing to the character A. Now, similarly, you can have a double pointer, CPP is the double pointer, so which contains the address of single pointer. Suppose its address is 2000, so it contains 2000, so it is pointing here, that means it is indirectly pointing to that value A only. Okay, same way we have written CP contains the address of I and CPP contains the address of CP. Double pointer contains the address of single pointer contains the address of the simple variable, and you can display. So double star CPP is nothing but if you are printing in the percentile D format, then it contains character A. Its equivalent ASCII value is 65, so you will get the output as 65. Similarly, if you want to see in the form of character, you will get A. Okay. Now, what is the value of I? I, if you want to see in decimal format, you will get the value as 65. Now, we'll go for triple pointer. If the level of indirection still increases, we can say that a triple pointer holds the address of a double pointer. Then a double pointer holds the address of a single pointer. Then a single pointer holds the address of a simple variable. So, there is three level of indirections. For example, this example, initially x is equal to 10. So, x will have some address, suppose it is 1000. Now, star p, double star pp and triple star triple p. So, here star p, p contains the address of x, that is 1000. That means it is indirectly pointing to 10. Now, this pointer will have its own address, suppose it is 2000. Now, the double pointer contains its address. So, it is now pointing to this. Similarly, this pointer will have its own address. So, you have a triple pointer which contains 3000. That means the triple pointer pointing to double pointer points to single pointer points to the value. So, there are three levels of indirection. So, all the pointers are indirectly referring to the same value 10 only. Okay. Now, you can display their addresses and values like that. Now, after learning about the different types of pointer, let us learn about what are the arithmetic operations that we can do on pointers. So, basically, there are two arithmetic operations you can perform. One is called addition and one is called subtraction. So, let us understand through one example. Suppose there is an integer array containing the 5 values. A is an array containing 5 values, 10, 20, 30, 40 and 50. And there is a PTR, star PTR is a pointer. Okay, this pointer contains the address of A. That means suppose it has a starting address 1000. So, this pointer is pointing to the beginning of the array 1000. Now, you know that this is an integer array. The size of each integer is 4 bytes. So, what will happen? Suppose this address is 1000. The second address will be 1004, 1008, then 1012, then 1016 and 1020 and so on. Now, what we are trying to do here? We are doing PTR is equal to PTR plus 2. That means what you are doing? PTR contains starting address plus 2. Plus 2 means the two locations we are talking about. So, what is the value it is referring? So, this is PTR of 0. PTR is nothing but it is referring to PTR of 0th location. 0th index is 1000. PTR of 1 is nothing but 1004. PTR of 2 is nothing but the value 30 it is referring. So, PTR plus 2 whenever you have done the arithmetic operation, that means the pointer is referring to the third slot. It is now referring to this slot. Okay. Now, after this, what do we want to do? We want to print the value in that location. Now, PTR is now pointing to it is no more pointing to the first one. It is now PTR plus 2. So, it is pointing to the third slot. So, now star PTR means the value in that address. So, the value in that address is nothing but 30. So, here you will get the address 30. Again, we have done PTR is equal to PTR plus 2. Again, pointer has been incremented to the next. So, it is earlier it was 1000, then it was changed to 1008. Now, again, 2 more locations. So, now it is pointing to your 1016. Now, star PTR, what is the value it is pointing? It is pointing to 50. Okay. Now what we are doing? We are trying to modify the value. Star PTR is equal to star PTR plus 2. So, the value star PTR contains your 50 value. Star PTR plus 2 means the value 50 will get added with 2. It becomes 52. Okay. Now, this is the value is changed now to 52. Now, what we are doing? PTR is equal to PTR minus 1 we are doing. That means we are doing the modification in the address. So, PTR was earlier 1016. Now, it is modified to the 4th location's address, which is nothing but 1012. So, that means it is no more pointing to this, no more pointing to this. It is now referring to 40. Okay. Now, we are displaying what is the value in that location, which is nothing but 40. Similarly, if you will put it into a loop and if you want to see what are the final values that is there in this array, then you can display each and every location value, which is nothing but 10, 20, 30, 40, and the last one you have modified through pointer, which is now 52. So, this is called doing simple arithmetic operations using pointers. Now, let us discuss about how to do arithmetic operation through another example. For example, x is equal to 10 and y is equal to 20. Two variables are there. And we want to do addition and subtraction using pointers. Now, P1 and P2 are the 2 pointers. So, P1 contains, suppose the address of x is 1000 and address of y is 2000. So, P1 contains the address of x 1000, it is pointing to 10, and P2 contains the address of y, which is pointing to 20. Now, we can simply write sum if you want to do. So, sum you can directly do x plus y. If you want to do indirectly through pointer, then you have to write star P1 plus star P2. Because P1, P2 are addresses, star means the value inside that. So, which is nothing but 10 and 20. Similarly, subtraction you can directly do, otherwise you can do. Now, you can do the addition using pointer and you can do the subtraction using pointer, and the value of addition subtraction you can display. So, which is nothing but 30 and 10. This is called doing simple arithmetic operations on pointers. Now we'll go for one more example where multiple pointers are pointing to the same address. Now, what do you mean by this? Okay. For example, x is a value, float type value, which contains 8.99. So, this x will have some address. Let us say it is 2000. Now, P1 and P2 are 2 pointers. P1 is a pointer and P2 is another pointer. Now, P1 contains the address of x. So, P1 contains 2000, which is nothing but the address of x. That means P1 pointing to 8.99. Similarly, P2 is equal to P1. This is called assigning the address of one pointer variable to another variable. So, P2 and P1 contain same address. So, it is also 2000. That means P2 is also indirectly pointing to the same value. Okay. Now, you print the details. Suppose address of P1 is nothing but, suppose this is the actual address. Address of P2 is also same because both P1 and P2 are pointing to the same location. Now, the value at P1 is nothing but 8.99 and the value at star P2, that is also same value. So, this way the multiple pointers can point to the same location also. Now, let us discuss about pointer with a string. Okay. Suppose we have a string. Now, how to store this string? This string is stored as like this. Welcome to. This is welcome to pointers. So, this is a big string. Okay. Now, this string will be ended by always null character and the name of this string is str and the locations are from, the index positions are from 0 to 19, for example. Now, so string always contains basically the character arrays, or array is a default pointer. So, the array name itself can be used as a pointer here. So, if you will print percentile as the string, the complete string will be printed because the name itself contains its own address. Arrays are default pointers. Now, we can also write, if you want to print character wise, we can write star str percentile c. Percentile c, str contains its address. So, star str means the str contains the address of the beginning of the array. That is called, suppose the starting address is 1000. So str contains 1000. Because the array name can be used as a pointer name. So str of 0 means it is pointing to star str means it is same as str of 0. That means it contains the address of the 0th location. So what is the character present? That is W here. The same thing I can write here as str of 0 without using pointer concept. With using pointer concept, I can simply write star str. Without using pointer concept, I can use the indexing mechanism. So I can write str of 0. That means it will also give the character W which is there at the 0th location. This can also be written like this. str plus 0. That is str of 0 is written as str plus 0. Okay. And str plus 0 in that address, if you want to use it as a pointer, so in that location, which character is there, which is nothing but W only. Similarly, str plus 6. str contains the starting address plus offset is 6. So in that, what is the character present? That is nothing but E. Then similarly, str plus 0. If you will give, that means you are giving the starting address, offset is here. This is called offset. This offset is 0 you are giving. That means the percentile S you have written. That means it will print the complete string from the beginning. So welcome to pointers. You will get it. Now similarly, str plus 3. That means from the, without using pointer concept, you want to print the string from the third location. So it will print from the third location the remaining part of the string. Thank you so much. In this video, we have learned about introduction to pointer concept, types of pointer, and what are the different pointer variants, followed by the arithmetic operations on pointers. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.